Hi guys, welcome to this video where we're going to be looking at cube roots with variables. So this is another part. The first part was looking at square roots with variables. So if you didn't watch that part, please go back and watch that part first. So if you're given to find the cube root of, let's say, a exponent m, all you have to do is think about this m. Is it divisible by 3? Why 3? Because cube is 3. Square is 2, right? So this is cube, so it's 3. Is it divisible by 3? If it is, all you have to do is just get your a and then m divided by 3. Let me give you an example. If they give you x to the 6th and they tell you to find the cube root, look at 6. Is it divisible by 3? Yes. So same as having x, 6 divided by 3, which is 2. So you get x to the 2nd. Same applies if you have maybe z to the 12th, and then they ask you to get the cube root. All you have to do is just get this 12 divided by 3. So 12 divided by 3 is a 4. So you end up with z to the 4. That is if the exponent is divisible by 3 or is a multiple of 3, same thing. Now, what if it is known? Break it down so that it is. Let me give you an example. So they give you a z to the 7 and then they ask you to get the cube root. First of all, 7 is non-divisible by 3, but I know z to the 7 is the same as z to the 6th times z to the 1st, right? Now, if I want to get the cube root, I would just get the cube root of everything this side as well. So this is divisible by 3. 6 is divisible by 3. So you get z to the 2nd cube root of z, something like that. And that will be your answer. Remember, we're simplifying. So let's look at a few examples, right? So they're telling us to get the cube root of x to the 3rd, yeah? Look at this exponent. So this is the same as x to the 3rd divided by 3, and this gives you x to the 1st. Mind you, x to the 1st is the same as x, yeah? Okay. Now, see this 64? The cube root of 64, we know is 4, right? So this gives you 4 already. But m to the 9, you just get m to the 9 divided by 3. And this gives you 4m to the 3rd. Now, sometimes you are going to be given radicands that are non-divisible by 3 and they tell you to get the cube root. They want you to get the cube root of 512 xy to the 10th. Okay, so break this down. Is 512 a perfect cube? Yes, it is a perfect cube. And the cube root is 8. Now deal with x. Looking at x, we're going to leave it the way it is, the cube root of x. Now let's deal with the cube root of y to the 10. Now, if I want to get the cube root of y to the 10, 10 is not divisible by 3, but I can break it down to y to the 9th times y. So if I get the cube root of y to the 9th and the cube root of y, this would give me y. 9 divided by 3, you get 3. Y to the 3rd, and then the cube root of y. Now, that means this whole thing will be 8 y to the 3rd, and then you write one cube root x like that. So instead of writing separate cube roots, they can be the same cube root, right? So that's what you get. Now let's look at the last example. Now let's start with 128. 128 is not a perfect cube, so I have to break it down into two numbers, multiply them, get 128, and one is a perfect cube, and that is 64 and 2. So I get the cube root of 64, get the cube root of 2, and the cube root of 64 is 4. So 4 times root of 2. So that simplifies like that. Now 9. Is 9 divisible by 3? Yes. Cube root of a to the 9th will be a. This is a, right? 9 divided by 3, you get 3. 21. Is 21 divisible by 3? Yes. So b to the 7. So this will be 4a to the 3rd, b to the 7th, and then the cube root of 2. That will be your answer. Alright guys, thank you for watching this video. I'll see you again in my next video.